the home learning classes present a most important content about vestigial sideband filter. As the home learning classes has a platform of quality and smart learning. So, in this, we are going to discuss about sideband shaping filter of VSB-SC modulation scheme. We consider two things. The first consideration is our unit step frequency function, that is UF, and this is shown in the figure. And the second, we have new low pass filter which has transfer function HVF that has odd symmetry about zero frequency, and as per this odd symmetry, the HV minus F is equivalent to minus HVF. As per consideration of both the point and the main requirement of vestigial filter, that is corresponding to HF minus FC plus HF plus FC, that is equivalent to constant for a frequency interval with respect to modulating signal bandwidth. So the two property of sideband filter are considered. The first property is that the transfer function of the sideband shaping filter exhibit an odd symmetry about the carrier frequency FC, and that gives HF, that is equivalent to UF minus FC minus HV F minus FC with a frequency range from FC minus FV to FC plus omega, and omega is the bandwidth of our modulating signal. Now, as per this equation, the first term represents the frequency shifted version of unit step frequency function, and the second term represents the frequency shifted version of new low pass transfer function HVF with their corresponding odd symmetry property about zero frequency, that is HV minus F is equivalent to minus HVF. Now the second property is that the transfer function is required to satisfy the condition only for frequency interval minus omega to omega, that is frequency representation of modulating signal, and that is equivalent to HF minus FC plus HF plus FC is equivalent to 1 for the operating frequency of modulating signal. And with this two property, our sideband shaping filter is equivalent to our vestigial filter as per the requirement. As per this expression, you are not going to cram the portion. You only understand the concept behind every content. And the practical implication of the second property is that the transfer function of the sideband shaping filter can have the arbitrary specification for an operating frequency range as per our modulating signal. Now another interesting thing that we consider the special case, as we have in DSPSC, as we have in SSPSC, now we have in VSB-SC. Now here we consider the modulating signal, that is MT, which is equivalent to AM cos 2 pi FMT, and its transform in frequency domain is equivalent to AM by 2 bracket start delta F minus FM plus delta F plus FM. Similarly, we have the carrier signal, that is equal to CT, that is equivalent to AC cos 2 pi FCT, and we have their frequency domain behavior, that is equivalent to AC by 2 into delta F minus FC plus delta F plus FC. Now we have the VSB-SC representation by considering a factor K that will provide the attenuation in upper sideband, and the factor 1 minus K that will provide the attenuation in lower sideband. So by utilizing K and 1 minus K factor, we have VSB-SC modulated signal that is equivalent to 1 by 2 into K into AM into AC cos 2 pi FC plus FMT plus 1 by 2 into 1 minus K into AM into AC cos 2 pi FC minus FM into T. Very important. K factor attenuate the USB signal and 1 minus K factor attenuate the LSB signal. And this equation is also reformulated as the linear combination of two sinusoidal DSP signal, and the final equation is equivalent to 1 by 2 AM cos 2 pi FMT into AC cos 2 pi FCT, that is in phase component, plus 1 by 2 into 1 minus 2K AM sin 2 pi FMT into AC sin 2 pi FCT, and that is quadrature phase component. Now, very important thing, this attenuated factor is defined in the interval from 0 to 1. Now, the most important outcome of this expression, if we consider the value K between 0 to 1 by 2, then we get the attenuated version of USB define the vestige of VSB-SC signal. And if the factor K has the value from 1 by 2 to 1, then it is attenuated version of LSB define the vestige of VSB-SC signal. If the K is equivalent to 1 by 2, now this is our DSP-SC signal. And if K is equivalent to 0, this is corresponding to lower SSB-SC signal. And if K is equivalent to 1, this is our upper sideband SSB-SC signal. So, with this expression, we can say that the DSP-SC or SSB-SC are the special case of VSB-SC signal. Now, this VSB-SC signal is transmitted through communication channel, and at the receiver end we get the received signal that is equivalent to 1 by 2 into AM cos 2 pi FMT into AC cos 2 pi FCT plus 1 by 2 1 minus 2K into AM sin 2 pi FMT into AC sin 2 pi FCT. And similar to DSP-SC as well as SSB-SC, we have synchronous detector here, and by utilizing the local oscillator signal, that is CT is equivalent to AC cos 2 pi FCT, we get the demodulated output, and this demodulated output is passed through low pass filter which have their cutoff frequency is equivalent to maximum modulating frequency or baseband signal bandwidth, and we get the estimate modulating signal that is equivalent to this. So this is total homework done by home learning classes only for your quality and effective content for your better learning outcome.